is our little project, and NARKISSOS-1 is our first spacecraft. So I'm going to go over a quick introduction. I'm going to tell you everything about NARKISSOS-1, where the project stands and where it will be heading, about the launch and about how NARKISSOS-1 can be operated, and then what we're planning for the future. So why did we do SpaceBooth? Why did we start that? So we strongly believe that space should be accessible to everyone, so it should not be expensive, not just scientists or engineers, and it should really become a part of everyone's daily life. We also believe that just like software, and I'm originally a software guy, so space systems are best developed in short increments. So if we can achieve to deliver and launch working increments of a spacecraft every 6 months and get quick feedback on how it works, what goes well, what goes wrong, that would be a perfect situation to improve, launch again, and improve again. And the small and cheap, in of course quotation marks, are the ideal platform to do that, and that becomes more and more accessible nowadays. We also believe that amateur radio is ideal for experimenting with new radio technology. There's a large motivated user base. We can do mistakes, and we can experiment a lot. And we have a lot of experts, like all of you, that are willing to chip in with their expertise. And then it would be nice if we can integrate space into social media. Social media is what's hot these days. So if we can reach a large global audience for interest in space through that medium, that would be nice. So I actually have a small video that some of you have already seen, as I've heard, but I will show it anyway, which explains it a bit in non-technical details, what it's about.
Always wanted to hang out in space but couldn't afford it? Now you can. How about your very own free space selfie? Want one? Here's how. To get started, take your selfie just the way you're used to. In the SpaceBooth app, select the picture you want to send into space and hit the send button. Your photo is now being transmitted via the internet to our ground station, and from there to our satellite. Once it's been received by our satellite, your photo will be converted into the right format and projected in front of the satellite's window. The onboard camera will now take a photograph of your picture, including the outer space background view. The result is then re-encoded and transmitted back to Earth. When ready, you'll receive an email notifying you that your space selfie is available for download. Now all you need to do is enjoy and show off. SpaceBooth, your selfie in space.
So that was a little bit of advertising, right? But to the serious stuff. So NARKISSOS-1 is the name of our first spacecraft, and we did choose that name for a quite obvious reason. It goes back to the Greek mythology, where Narcissus was the deity that fell in love with his own reflection. So we thought that people who love their own reflection certainly would be interested in taking a lot of selfies, which is why we came up with this name, NARKISSOS-1. So, how will this look like? So it's a satellite that's intended for the low Earth orbit. It's based on Interorbital Systems CubeSat kit. It's an American company in California. It has the shape of a hexadecagonal tube. In height, it's about the size of a smartphone. It's a little bit wider than that, and it has a number of subsystems. So we have the antenna, the solar cells. We have a power management system, a radio, obviously. We have an emergency shutdown system, our OBC, a camera, and a projector display. So the OBC is based on an Arduino Mini 05. The radio uses the radio matrix TR2M plus an amplifier to transmit to 100 milliwatts. We use AX25 with 1200 bits per second, and yeah, we might consider replacing it after hearing the previous session. Downlink on 437 megahertz. It works in one in, one out fashion. So basically, we have two buffers in the satellite where you will, in one pass, you will uplink one picture, and in the next pass, you will try to downlink its result, and you will never have more than one picture in the buffers to increase reliability. So we did actually do some research in using SD cards for storing pictures, and that would have allowed us probably to store more, have more storage space. But what we learned is that SD cards might get damaged during launch due to the vibrations, and also they are quite they consume quite a lot of energy, which is something we can't afford. So we went for non-volatile EEPROM memory buffers. We only have limited telemetry, so we downlink the battery status and the temperature, and we don't have attitude control yet. All the components are commercial off the shelf. We have the Adafruit camera that is quite well known, I think, and already was used once in a space mission, if I recall correctly, plus a specific lens for our purposes, and a Freetronics OLED display, which is the one that the only one we could find that we tested in heating and still performed well. So and that's the display used as a projector. You have a custom-made satellite projection lens, and you have to this is a CAD model, but you have to imagine this as being transparent. And you have hexadecagonal transparent window, if you will, and you have the projection lens attached to it. So this is a model of how the CubeSat satellites look like. This is actually not our own satellite. It is an illustration of the CubeSat satellites to give you an idea of its size and its shape. And yeah, the antennas are indeed made of the steel tape measures. So the first of our boards that I'm showing you here, this is the antenna board. You can see the switch that will initiate deployment and start up the OBC. Solar cells, so we are using these triangular task cells, and we have 8 of these solar cell PCBs attached to the outside of our satellite. Power management, so yeah, we have a battery attached here, so the solar cells that will store the energy in this battery. Then the radio board, so this is the radiometrics transceiver on 437.290 with an amplifier so that we can transmit maximally to 500 milliwatts. And actually this small pin that you can see at the top is actually one for our emergency shutdown subsystem that we presented. Yeah, the back of our transceiver board, where we actually implement the transistor switch circuit that will enable and disable the transmitter. So about its shape, so it's not very big. It's actually quite small, and it weighs about 3/4 of a kilo, and it will probably go up still a bit in weight, and we have a maximal limit for our launch to go to 1 kilogram. So we probably go that far, I guess. The cost of the satellite approximately $18,000, which excludes the launch costs. And it will have only a very limited lifetime in orbit, 3 weeks to 3 months of 310 kilometers of altitude. It will completely burn up when falling back, so it will leave no space debris. So where do we stand? So we started the conceptual progress in October 2013. We started actual building of the satellites in January. We completed frequency coordination with IRU on end of April. Currently, we're doing the integration testing, so we have all the separate components, and we are currently integrating them and doing the testing. And we are planning a launch, which we actually have been manifested already on Interorbital Systems Launch Manifest for Q4 2014. So these are the stages of our project. So we started design and prototyping. We went on satellite development and building. Now we're doing simulations and testing. We're actually using the a very handy MATLAB toolbox by Princeton Satellite Systems, which does very nice simulations for CubeSats, and they actually added the TubeSats as well on our request. So that's quite easy to simulate how our satellite will fare in orbit. Then we need to do the front-end development, and we will do then hopefully launch, and post-launch will be successful. So the launch is planned, like I said, for the end of 2014. It will be provided by Interorbital Systems, and it will be launched in California, actually from the sea, on some private island that's about 150 miles off the coast of California. It will be launched together with a maximum of 22 other CubeSats, but that's obviously to be determined. And they use a Neptune launch vehicle that's specifically designed to launch CubeSats. And that's also actually why they have this form of a tube, because the entry points for the satellites are round. So yeah, this is you can see the on the back you can see the launch tube where it will be inserted in, from which it will be deployed, and then the antennas will automatically deploy from themselves once they're launched outside of this tube, of the cylinder actually. About the orbits, it's a circular polar orbit. There's a lot of information. I'm not going to go over everything. So the altitude will be about 310 kilometers. Yeah. So right. So if you want to operate our NARKISSOS-1 satellite, so as a licensed radioamateur, you can communicate with it directly. So it will not talk unless talked to, except for its beacon, of course. So you can send a start upload telecommand before you start uploading an image to it, and you can send a receive buffer telecommand to downlink. We will provide scripts to encode and decode images, because the satellite accepts only it can only handle images that have been encoded in a specific hex format. We will provide a telecommand guide on exactly how to operate the satellite, and just general information on receiving NARKISSOS-1 once we know more. And yeah, of course, if you downlink a picture that you haven't uplinked, then we would like to know about it, right? So that we can get it to the correct person. Also, clearing out the outgoing buffer can be done automated and not necessarily. So we have a mechanism to, if you don't succeed to download an entire picture in one pass, then we have a mechanism to retain the data that has not been downloaded yet in the buffer, and you can get it on a different pass, or also gaps that you need to be filled can be requested in the next pass. So, which means that the outgoing buffer will not be cleared every time automatically, but of course it needs to be cleared before it can accept any new incoming images. So that's if you're a licensed HAM user. If you're not, you can also you can just use our web interface and basically send your picture to us, and then we will on our ground station we will send it to our satellite and hopefully get it back to you. So like I said, the selfies are converted to a specific hex format before transmission. We append an identification code to each of the images that we sent, and you get those back when you downlink an image, so that you can identify where it belongs. Yeah, so there's no NARKISSOS-1 does not support any scheduling, so you cannot send a number of telecommands to it, and that it will process automatically. What it does do is, once it receives an image in the buffer and it can read it, it will automatically project it and take a picture of it. So it will do the processing automatically. You don't have to start it manually by telecommand. Sorry. The queue and buffer management is semi-automatically, like I said. So sometimes the buffer will be cleared automatically, and sometimes you will have to do that by telecommand. There's like beaconing and downlink of telemetry, and we don't support any field updates for the software in this iteration. We do support updates of some parameters in the software that can be updated, but we cannot update the entire software on the OBC. Where are we going? So we hope to launch more iterations of the space Selfie mission. So we're actually already working on NARKISSOS-2. We want to include attitude control, most likely passive, but active would be nice, but probably not achievable. Improvements in image quality, yeah, I didn't mention that, but the downlinked image will be of a VGA resolution, so 640 by 480, which is good but not great. Radio communication is slow, so we use AX25 over 1200 bits per second, and it's quite challenging to downlink an image in one pass, or uplink or downlink an image in one pass. Using that protocol, so we are looking to improve that. We have more telemetry, positioning data, more advanced command systems, and so forth. So there's a whole lot of stuff we would like to improve here, and of course also general improvements that we don't know yet about, but we will get once the one is launched, and see what's going wrong and update it and perform better on the next iteration. We also have new missions in the pipeline, so it's not all about space selfies, of course. We have other missions that include planetary photography of observation that we are currently working on conceptually, of course, but they will probably all use the same format, meaning size-wise and cost-wise of the satellite. And yeah, what basically our main mission is to make space more accessible to the general public. So, with that being said, I don't know how was the time. Questions?
Okay, thank you very much for a very interesting presentation. It's very exciting to see social media and satellites being combined. It's difficult to know where to start with a list of questions in my head, so I better limit it to just perhaps one.
There's time.
You have images being sent up from the Earth. Mm-hmm. You have the same image retaken, sent back down to ground. The data rates required to do that are going to be quite slow. Don't you think, with the popularity of social media today, the entire capacity of your satellite will be used up within the first half an hour of it being opened up, and you'll have a lot of disappointed people?
Certainly.
Would it not be possible to send the pictures back down to ground and then incorporate the selfie image in an application on the ground, and that way you wouldn't have so many disappointed customers, as it were?
Or use Primal Studios.
Exactly. So it will, of course, it would be it would of course increase the number of photographs that can be processed dramatically, but it takes away from the authenticity. And basically, and yeah, it's indeed true. We won't be able to process many images, and it's never been the intention to do that. It's an experiment. So we're actually experimenting with how to compress images better, how to uplink, downlink. These are the things that we're working on, that we're looking at, and this is it's not some kind of new social media network that we're working on. It's not something that we want to have millions of users sending up their pictures every day. We're not like a Twitter or YouTube. It's just we want to include the general public, have an application that everyone can understand, but mainly in itself we are working on technology, on radio communication technology, and how to work with images, uploading and downlinking images. That's the main purpose. And if we only do 10, we process 10 images, then we would be very happy.
Hi. Just to tell you that I am the designer of the CubeSat concept for iOS company. So you can see my call sign on your PCB.
Yes.
So if you have any question, you can ask me. And just to tell you that the launch date of end of this year is very, very optimistic. I know the company.
Yeah, I know. I talked to Randa, but you know Randa, I guess. But yeah, we'll see.
Yes. Any other questions? Right.
Hello, it's very interesting. Thanks very much. But I just wondered what kind of, if guarantee's a big word, that you on your selfie you'll have a picture behind you of something quite interesting, like the Earth, for example.
None at all. It can be
just
black.
Some stars.
Yeah, it can be black every time, many times. Like I said, there's no attitude control, so it'll be spinning.
So would you think of adding attitude control in terms of gyroscopic control or something like this?
Yes, we're definitely thinking of that. But
with specific positioning?
Yes.
Okay.
But it's not going to happen for this iteration, but we're definitely thinking about that. Yes.
Okay, excellent. Thanks.
I'm just curious about the quality of the image. If you'll focus on the projection, what would you see in the background? It will be a complete bokeh, blurred, no?
Yeah, we did some tests on that. So we tried to simulate the environment as well as we could, and it is quite challenging because the camera is quite close to the projected image, and you will have a lot of bright light very close to the camera's lens. And that's why we did have to go and look for a very specific lens to be able to see the image and still have a quite acceptable background view. And we think we managed to get some kind of good intermediate solution for that. So a good. So I guess we do downgrade a bit on the quality of the focus image, so the image itself will be a bit less sharp than you might expect, but I think the overall picture will be acceptable. Yes. But indeed, that is also, like I said, part of our experiment.
It seems a lot of interest on the internet from people wanting to put their own pictures on. It's going to be quite a sort of transient interest. Have you got any plans to make them engage a bit more and work towards have to achieve something themselves before they can put their own picture up, rather than just paste the picture, think it's cool, and that's it, that's the end of their involvement?
Yeah, we have thought about it. We haven't come up with anything concrete. We have thought of auctioning guaranteed spots for charity, stuff like that. So because the number of images that we can process, like you said, is very limited. So indeed, we are thinking of how to select which images we will be uplinking, of course. And yeah, the easiest way to bypass the selection, of course, is being an amateur radio operator and sending it directly yourself. But indeed, we have thought about it, and we have not come up yet with any concrete way. So if you have any suggestions, we will be very happy to hear them.
Okay, thanks for your presentation. Is your main American market going to be in America? Because you used an American voice there. And is that where you think your target market will likely be?
No and yes. So no, it's not. We did not use an American voice specifically to target the American market. But yes, if I had to bet on it, I would say probably yes. Probably there's going to be a market.
I can understand you fine.
Yes, but no, the voiceover, it was just cost effective.
Okay, I have shortly two questions. One, do you check the images on board? For example, if you take a picture facing to the sun, then it most likely overexposed. So you do check that before you transmit it down to ground?
No.
Okay, and the second one is, how do you finance the satellites and then the operations of the ground equipment?
Sorry?
How do you finance the satellite and the ground segment? Like, I mean, the server needs power, then internet connection, etc.
Yes, indeed. So for the ground segment, we have found some partners that are willing to help us out. So we have multiple ground stations. Well, I'm not going to say all over the world, but some ground stations a bit geographically distributed, and indeed for the servers, that's the same. For the satellite, for the launch, we have a corporate sponsor. And for the satellite itself, it's our own investment. So for the parts, time, labor, and all that simulations, it's our own investment.
Thank you very much indeed, Emmanuel.